Hello, so I am going to be presenting my arc length project and going over a path and then coming to a conclusion at the end of this presentation. So my name is Olivia Domski and let's get into it. So my path and its reasoning. The path I chose is at Indian Hills High School in Oakland, New Jersey, which is where I'm from. And this path is on the track they have at the high school where I practice running. Specifically, I need to practice running a mile. I chose this path because I need to practice running a mile the fastest I can for an upcoming fitness assessment I have for certain colleges I'm applying to. But when I run this mile, I usually stay in the leftmost lane each time. I run around the track 4 times in the left lane, but this route is probably shorter than a full mile. Therefore, I want to find out how many feet my usual path is short of being 1/4 of a mile and how many times I actually need to run around in the leftmost lane to complete a mile. So here is a picture of my path on the left, and to the right, I made a bunch of little lines to try to get the specific length of the path, and Google estimated this to be 0.25 miles, but this is my path. But disregarding the multiple line segments as the curves, we're actually going to be now calculating the arc lengths on each side. And since each vertical side of the track is 349 feet, we're going to say that arc 1 is the same length as arc 2. Therefore, we only need to calculate the length of 1 and then just multiply it by 2 at the end. So for the arc, in this case, we were looking at arc 2. Here are the points that I found. Using the measurement tool on Google Maps, I found that I made the points of negative 108, 0, negative 54, negative 69, 0, negative 83, 54, negative 69, and then 108, 0. And these points will come into play when we're using the arc length formula later on in this video. So now I did quadratic regression using Desmos. Here on the left, we have the points that I just mentioned, and these points I plugged into Desmos on the table, and then from there, use quadratic regression to find an equation that best fit this curve that we found, or this arc. And this equation was right here at the top. And then using my graphing calculator, I found the derivative of this equation to be right here, which is 0.0148932x. This is the derivative. Now we will use this derivative in the arc length formula. Up here at the top, we have the arc length formula in terms of x, which we were able to use in this case. Now, looking over here at the arc length formula in the middle, we see, like I said, these other points come into play where they were the x-intercepts. So we plug in what we already know. We plug in the derivative, and we plug in our b and our a. And we find that one arc length is 288.713226 feet. So going back to the path that we had before, the path length is 1,275.43 feet per lap in the leftmost lane. So in conclusion, my usual lap in the left lane is 1,275.43 feet. 1/4 of a mile is technically 120 1,320 feet. This means that my path is 44.57 feet short of being a fourth of a mile. Also, if I wanted to run a full mile while being in the leftmost lane the entire time, I would have to run around the track 4.14 times as compared to 4 times if I ran a lap that was 1,320 feet. So in other terms, I need to run around the track 4 times plus an extra 178 feet, which is about half one of the straight side lengths. So looking over here on the right, I would run around the pink, I would run around 4 times, and then the blue dotted line would be the extra feet I would need to run if I decided to run in the leftmost lane, meaning that it's the closest to the grass the entire time. Thank you for listening.